Greetings everyone, and welcome to the next video in my lecture series on statistics. Today's example, we're going to do a conceptual example with mean, median, range, and standard deviation. So the question is, the Gizmo store has to raise its prices because of a platinum shortage. Every device sold in the store has a different price, and you may assume that there are many devices. Part A. If every device has its price increased by $5, what happens to the mean, median, range, and standard deviation? Be as specific as you can. So there's two different ways of thinking about this. The first is, well, if you actually look at it and you immediately know what the answer is, you could just write it down if you've got some good math aptitude. We're going to also try to think through this more carefully if it's not immediately obvious. So let's just scroll down here to mean, median, range, and standard deviation. Okay. So one thing we could do if we wanted to think this through is we could say, okay, let's suppose, for example, that there are something like 5 devices, and we have a little sketch of before, and we have a bunch of different prices like this, and then after, everything's been moved up by $5. And who knows how much that is, but let's say that it just shifts a little bit to the right. So hopefully, because this is I've sketched a little symmetric guy, it looks like the mean has moved up by the same amount. If these are nicely symmetric about that middle point. And the amount that it shifted was by $5. And so it looks plausible that the mean would also move by $5. The median would be, in fact, this middle value, and it is also shifted up by $5. And so then we would write that the mean and the median have increased. Use blue here to be consistent. Increased by $5, and the median would have done exactly the same thing. Now let's take a look at the range. The range is the difference between the max and min values. And if you notice that because the min and max have both moved to the right by $5, the length of the little sort of line that I've just drawn here would be exactly the same, and so you'd expect that the range would be the same. The standard deviation also is a measure of how far apart the points are with respect to the middle. And if you notice that what we've done is we've done a shift where every single value has moved to the right, but the shape of the distribution hasn't changed, and therefore the standard deviation would also remain the same. Now, if you're not comfortable with doing what I've done with the little graph, a different thing you could do is you could actually make yourself a little numerical example. And you could say, before, we have 10, 20, 30, 40, and 50, or whatever numbers you happen to choose. I've made this nice and symmetrical so you can see that calculating the mean will be easy to do, but you don't have to do that. You could just do some random numbers. After we'll have 15, 25, 35, 45, and 55. And you could go ahead and actually compute the mean for this if you wanted. You'll find the mean value is our middle value of 30. For the after, our mean value is going to be our middle value of 35, and so the mean and the median are also going to be the same values for the two data sets. And so the mean and the median from before to after have just moved up for $5. Remember, the median is the middle value when we've written it as an ordered list. And so both the mean and the median get the same answer as before, which is that they have increased by $5. Now notice the range here. The range is the max minus the min. And so it's going to be 50 minus 10 equals 40. And for the second one, it's going to be 55 minus 15 is equal to also 40. And so that's where we come to the conclusion that the range stays the same. And we've also said what happens previously when we were looking at the standard deviation. We noted that if you take all of the points in a data set and simply shift them to the right, the shape remains unchanged. The relative standing, or where everything is with respect to the center, doesn't change, and therefore we can continue to conclude that the standard deviation will stay the same. Okay, let's go on to part B. I'm just going to write this down here. So part B, oops, it helps if I write in actual ink. Part B, only one widget, or sorry, only one device needs to have its price changed. The most expensive device has its price increased by $25. What happens to the mean, median, and range? Do they increase, decrease, or remain the same? Okay, so again, we've got the two different approaches where we're going to, well, there's the three approaches of just looking at it and getting a feeling for it, but we're going to either draw a little sketch or alternatively just put down some numbers and see what we see from that. So let me just write here, mean, median, and range. So if we were to just draw a little picture, we've got before, try to write legibly here, there's before and after. Before, let's say we had 5 devices, and after we have, let's pretend that I'm actually drawing something that looks vaguely like the one on top, except that this guy has moved by $25. So let's answer the median first, because I think that's easiest. The median is this value in the top graph, and it's going to be exactly that same value in the bottom one. It's the middle one, and the middle one's value has unchanged, and so the median stays the same. If we look at the mean, when we add all of these values up in the top, if it's nice and symmetrical initially, we'll get the middle value, but in any event, we'll add all the sum together and divide by the number of points. For the after set of data, one of the points is increased by $25, and so the sum of all of the 5 data points will increase, and when we divide by 5, we'll get a larger number. So the median goes up. Notice that the question just says, do they increase, decrease, or remain the same? It doesn't say by how much. You don't have to figure that out. If you wanted to be very specific, it actually increases by 25 over n. In other words, you take the amount it's increased by, which is $25, and divide by the number of points, or the number of devices in this question. It wasn't asked for, but it's a nice little touch. Now notice here that the range initially was the length of this little line here, and then the range afterwards is the length of that little line there, and so the range increases. Okay, let's take a look at part C then. Oh, no, I should continue in the same vein. If you prefer, you could do the before you could actually just write out a little list of numbers, 10, 20, 30, 40, and 50. And you could do after 10, 20, 30, 40, and then 75, because that last one increased by, the most expensive increased by $25. If you calculate the mean of the top set, you'll get that it's a value of 30. If you calculate the mean of the bottom one, actually, let me just do that. Should have done that beforehand, but didn't. So, here we are. I'm just typing this into my calculator here. I get $35. So the mean beforehand was 30. I suppose I should have known that because we've just increased it by 25. We've got 5 points, and so that's an increase of $5. But the mean for the second one is 35. So again, the mean will increase. The median is the middle value, which in both cases here, actually let me change the color of my highlighter pen here. The middle value in both cases is the value of 30, and so the mean, once again, stays the same. So you've got the mean increasing, the median stays the same, and notice the range, which in the top one is 50 minus 10 is 40, and the bottom one it's 75 minus 10, which is 65, and 65 is greater than 40. So once again, we can conclude from our little numerical example that the range increases. Okay, let's do part C. All devices increase in price by 10%. What happens to the mean, median, range, and standard deviation? Hope you don't mind. I'm just going to abbreviate that by STD, standard deviation, and we're going to be as specific as you can. Okay, so what we're doing is we're taking a certain data set. So here's before. And we're stretching it out a bit, where the bottom one moves by a bit, the top one moves by quite a lot. And so it's sort of proportional here, where you've got sort of a bit more stretching as you go. I haven't done the best example of writing this out here. So the mean value has moved up. This is a little example symmetrical. So here's both the mean value and the median value, and they both moved up a bit. So it's still the middle value, but the middle value itself has increased by 10%. So the mean and the median have both gone up by 10%. Notice that the range, which before was this guy, has now increased. But that increase, again, is proportional to the constant that we put in. And so the range is also going to increase by 10%. And also, when we talked about standard deviation earlier, we had noticed that when you multiply, or I'd stated as a fun fact, that when you take a data set and you multiply it by a constant, the new standard deviation is the old standard deviation multiplied by that same constant. And so our conclusion is that all values, or all, just all increase, and by that I mean the mean, the median, the range, and the standard deviation, they all increase by 10%. Now, if you don't find that convincing, you can again do a little numerical example. We got before and after, and before we had 10, 20, 30, 40, and 50. And after we have 11, because of course multiplying by 10%, 10% of 10 is 1, so we get 11, 22, 33, 44, and 55. The mean value of the top guy is 30. If you add 11, 22, 33, 44, and 55, and then divide by 5, you'll find the mean value is, oh, why did I write 33? I do not know why yeah, no, 33 is right. Then you will get that the mean value is now 33. Notice that the middle value of these two data sets is 30 to 33, so a 10% increase. The range is going to be 50 minus 10 equals 40. The range on the bottom one is 55 minus 11 equals 44, so that's a 10% increase also. And then for the standard deviation, we're just going to go with our aforementioned fun fact, which is when you take a data set and you multiply everything by a constant. And what we're essentially doing here is when you increase by 10%, you're multiplying the value by 1.1. And so the new standard deviation is going to be 1.1 times the value of the old one. So it is all increased by 10%. So that concludes our little conceptual example on the mean, median, range, and standard deviation. Thanks for listening.